Morning, all of you. The topic for the discussion now is benzoin condensation. Topic is benzoin condensation. In this particular benzoin condensation, we are treating two molecules of aldehyde in presence of cyanide ion. We get the product benzoin. This is your benzoin. When certain aldehydes are treated with a cyanide ion, gives you benzoin finally as product in a reaction called benzoin condensation. In this benzoin condensation, this particular condensation is regarded as involving the addition of one molecule of aldehyde to the ketonic functional group of another aldehydic molecule. We have in this aldehyde, there is C double bond O and H. Aldehydic functional group is there. This is aromatic aldehyde. We have another CHO is there. Addition of one aldehydic functional group to another aldehydic functional group takes place in presence of cyanide, leads to the formation of benzoin in a reaction called benzoin condensation. Now, I'll try to explain you the mechanism how this benzoin is formed. Starting from our aromatic aldehyde, you take the first aromatic aldehyde, C double bond O and H. We are treating this with Cn minus in an equilibrium reaction. The addition of, this is a simple step in which the addition of Cn in one aldehyde takes place, leads to the formation of this. In the next step, another equilibrium, this particular proton moves here, converting this carbon into C minus, Ar, C minus, OH, Cl. This takes place. And this involves in the next step, like this. This particular C minus adds to another carbon of another aldehydic molecule. And this will give you this finally as product. Ar, C, OH, Cn, C double bond O, CO minus, Ar dash. And we have H also. Yes. And once this is formed, this will give you in the next step the proton of this, the OH will be removed as H plus, and this will join with this O minus, converting the O into OH, and the bond left over after the removal of this proton will move in between these. Simultaneous removal of Cn as Cn minus takes place, minus Cn minus. The product then is C double bond O, C, O, H, H, Ar dash. This is your benzoin. So benzoin is formed finally. This is a mechanism that explains how benzoin is formed in this addition, that is condensation reaction. We are taking the first step aldehyde, aromatic aldehyde, treating with cyanide. The Cn minus will add the carbon of the C double bond O. When it approaches the carbon, the pi bond between the C double bond O moved over. The O making the O now into, changing the O into O minus. In the next step, the addition of Cn into this carbon already taken place. The next step is movement of this proton. Changing the O minus into OH takes place, leaving the minus over this carbon, making this carbon a carbanion, C minus. This C minus in the next step will add to the carbon of another aldehydic molecule, and the addition has taken place now in this. The next step is the movement of this, removal of this proton to this O minus, converting this O minus, then because of this movement takes place O minus into OH, and the bond what is left after the removal of the proton will convert the C single bond O into C double bond O. Simultaneously, removal of this Cn into Cn minus takes place, and finally this leads to the formation of this particular benzoin as finally the product. Try to understand the mechanism, how the benzoin is formed starting from benzaldehyde. See the board, try to understand the mechanism what I have written on this whiteboard. Benzoin condensation is aromatic aldehyde. Certain aldehyde when treated with the Cn minus gives you benzoin as a product in a reaction called benzoin condensation. This benzoin condensation is regarded as the addition of one aldehydic molecule into another aldehydic molecule, that is another C double bond O of another aldehyde in presence of Cn takes place. And the mechanism is first benzaldehyde treated with Cn minus, converting you get this, and this then undergoes that type of thing because of the proton movement and making the C into C minus. That C minus will attack the second aldehydic functional group. You get the addition product, and finally that is a condensed product. After this, the removal of Cn minus because of this interconversion, because of this proton into O minus takes place. The bond is now moving between C single bond O. Simultaneous removal of Cn as Cn minus takes place leads to finally the formation of your benzoin as written on this particular board. This is the thing that I want to explain in this particular class. If you have any query or any doubt, feel free to ask me via your email, via the same Google Classroom. You can ask your doubts. Till then, with this I am concluding this particular session. Till then, goodbye.